Congratulations, you've made it to the end of section 8.4. We're going to put together everything we know from section 8.4 so far and a little bit of new stuff as well to solve recurrence relations with generating functions. Again, this is just a great reference for you to come back to look at whenever you need a little bit of help finding the right direction. So what we want to do is we want to be able to take a generating function that we've already learned how to solve. So we know how to solve this. This is a non-homogeneous recurrence relation. We want to figure out how do we solve it using a generating function. Now I'm going to take you through the process kind of slowly to begin with, and then in our next example we get to skip all of this stuff at the beginning. So the stuff at the beginning says let n equal 1, let n equal 2. Let n equal 3. Let n go all the way down to n equals n. And for each of them, essentially what I'm doing is I'm taking this recursive relation and replacing n with 1, replacing n with 2, and so on. And then I'm taking each term multiplied by x to the n. So I'm taking all of this times x to the first, all of this times x squared, all of this times x cubed, and all of this times x to the n. Then I'm simply going to line them up in the way that they are, and I'm going to combine them together. So I'm going to add everything. Now what I'm going to do is I'm going to add all of these first terms together. I'm going to take all of the second terms together. I'm going to take all of the third terms together. And if you'll notice, by doing that, they each become their own series of values. So each of these is now a1x plus a2x squared and so on. I've got minus 3a0 x plus 3a1 x squared and so on. And then my final sequence or series is 1x plus 2x squared plus 3x cubed and so on. Now, all I want to do is clean those up a little bit. Let's clean it up and rewrite it as a summation. So my first one, as I can see, I get a sub 1 x to the first. I get a sub 2 x squared, a sub 3 x cubed. I can rewrite that as a summation, and that summation is a sub n x to the n, where the first term is 1. So notice I've started with 1 here. So that is my first expression. So all of this represents the summation of those first products. Then I look at my second set of terms. I've got a 3 that I can factor out of everything. So let's just get rid of the 3. Notice the 3 comes out front. So now I have the summation of a sub 0 x to the first, and a sub 1 x squared, and a sub 2 x cubed. So I can see those values, that n value isn't quite lining up. So I'm starting with n equals 0 and a sub 0, but that first exponent is 1, so that means it's x to the n plus 1. So this all represents my second series. And then if I look at the last one, I can see that I have 1 plus 2 plus 3, and then it's x to the first, the second, the third, and so I can rewrite all of that as the summation starting at 1 of n x to the n. Now, what we want to do from here is we want to let g of x be the power series of the summation as n goes from 0 to infinity of a sub n x to the n. So as much as we are able, we now want to replace each of the 3 summations that I have as well as possible using the power series, if we can. So I want to replace whatever I can with g of x. So if I think about g of x, let's use a different color. Well, let's just keep with white. G of x, if you'll recall, says a sub 0 x to the 0 plus a sub 1 x to the 1 plus a sub 2 x squared plus a sub 3 x cubed and so on. So that's the generating function. That's the power series that we're trying to use. If you look at what I have in blue, I have a sub n x to the n, which is exactly what I want, but if you'll notice, I need it to start at 0 and this starts at 1. So if I think about the series that I would get with what I have boxed in blue, this series would be, starting at 1, would be a sub 1 x to the first plus a sub 2 x squared plus a sub 3 x cubed, and so on. So what's the difference between what I have boxed off in blue and the actual power series? Well, I'm missing a sub 0, a sub 0 x to the 0. So what do I need to do? Well, I'm going to take this generating function, this power series, and I'm just going to get rid of that a sub 0 value, and that's going to give me this. So how do I write that? I say take that generating function, that power series g of x, and just get rid of that first value, a sub 0. That's all I have to do for the one I have in blue. So now, as you can see, I'm replacing the first summation with g of x minus a sub 0. Now let's look at what I have in green. What I have in green is obviously I have the negative 3 out front, and I have it starting at 0, which is great, but what I have is a sub n and then x to the n plus 1. So again, if I were writing out the series, keeping the 3 out of it, of course, I would have a sub 0 x to the 0 plus 1. And then I would have keep writing x instead, a1 x to the 1 plus 1, which is 2. And then a2 x to the 2 plus 1, which is 3, and so on. Now, how does this compare to what I want for the generating, for the power series? Well, I need a sub 0 to have x to the 0. So if I take an x out of all of this, that would leave me with a sub 0 x to the 0, and a sub 1 x to the first, and a sub 2 x squared. So I'm going to rewrite everything I have written in green as not just taking the minus 3 out, or the 3, I'm also going to factor out an x. So notice I have 3x g of x. Now, whether you put the negative down here or not, I don't care. Obviously, we're going to keep the negative in the function. So now I have minus 3x g of x. Now, for our last one, I have the summation as n goes from 1 to infinity of n x to the n. That will never, ever be the power series. So if you have something like that that's not a power series, we're going to go back to what we know about those generating functions. So this specific example we actually went through in video 8.4.2, where we differentiated each side in order to come up with the summation starting at 1 would be x over 1 minus x quantity squared. So notice that's what I'm replacing in the function. So this is where I am now. G of x minus a sub 0 minus 3x g of x is equal to the x over 1 minus x quantity squared. From here, I'm going to just try to clean it up as much as possible. And what I want when I get to the end of this is g of x equals. So that's my goal, get g of x equals. So what I'm going to do is I'm going to rewrite this as g of x, and then a sub 0 I'm going to replace with 1. That was given to us at the beginning of this question. And then I have 3x times g of x. And then I have x over 1 minus x quantity squared. Now I want to add 1 to each side. And on the right-hand side, I'm not just going to add 1 because I want to add it to the existing fraction that has 1 minus x quantity squared as my denominator. So really I'm taking 1 minus x quantity squared over 1 minus x quantity squared, which is just a form of 1, right? So on the left-hand side, I have g of x. Those cancel. I have minus 3x g of x. Oops, Getting crazy with my parentheses over here. And then on the right hand side, I have x plus 1 minus x quantity squared, which I'm going to go ahead and simplify. I have x and then plus 1 minus x quantity squared over 1 minus x quantity squared. Now, I want to keep my denominator exactly as it is, so don't be tempted to multiply that out. However, in my numerator, I do need to be able to combine like terms. So I'm going to go ahead and find what is 1 minus x quantity squared and replace it right here. So what is 1 minus x quantity squared? Well, I would get 1 times 1. So again, I'm just thinking of this as 1 minus x, 1 minus x. I don't want to lose you along the way. 1 times 1 is 1. 1 times minus x is minus x. Minus x times 1 is minus x, so that's minus 2 x's. And then plus x squared. So what do I have on the right-hand side of the equation? Well, combining this x and this minus 2x, I would have x squared minus x plus 1, and again, over 1 minus x quantity squared. So notice I've simplified the numerator, but not the denominator. What's next? Well, again, my goal is g of x by itself. So this is 1 times g of x, and then minus 3x times g of x means I can write this as g of x times 1 minus 3x is equal to everything here on the right side of the equation. Nothing's changed on the right side for this particular step. And then the next step is to divide each side by 1 minus 3x, which means my final solution is x squared minus x plus 1 divided by 1 minus x quantity squared, 1 minus 3x. Now, before I would continue, you should always look at that numerator and say, okay, can I simplify the numerator? Will it factor? Can I get rid of any of the factors on the numerator and denominator? And the answer in this case is no. So from here, this is where we're going to pick up where we left off in the last video. So I have a generating function, and I now have to write it as an explicit solution. The next step is to find the explicit form of the generating function. So we have our generating function that we've just created together, and now we need to find the explicit form. So just as we did before, we're going to use partial fractions. So I'm going to write x squared minus x plus 1 over 1 minus x quantity squared, 1 minus 3x, is equal to, and this is where I use my a, 1 minus x, my b, 1 minus x quantity squared, because we have that double root there, and then plus c, 1 minus 3x. We should be getting really good at this point. We're going to multiply everything by this value. That's going to give me x squared minus x plus 1 on the left. A will be multiplied by 1 minus x, 1 minus 3x, because one of the instances of 1 minus x cancels. B will cancel with both of the 1 minus x's, which leaves me with 1 minus 3x. And c will cancel with just the 1 minus 3x, so I'm going to have c times 1 minus x quantity squared. Again, let's just do the math here. I've got x squared minus x plus 1. Here I'm going to multiply all of this out, and so I'm going to have a times 1 minus 4x plus 3x squared. I'm going to have b times 1 minus 3x, and I'm going to have c times 1 minus 2x plus x squared. Again, multiplying it out. So I guess I'm hoping if you're watching this video, you know how to multiply binomials. All right, from here, just as I did before, we're just going to get everything together. So all of the x squared values, which would be x squared, and that's going to be 3a. And then do I have a bx squared? No, I don't, but I have a c x squared. So I'm skipping a little bit of work, but I'm trying to explain it as I go. And then how many values do I have for x? Well, I have minus 4ax, so minus 4a. I have plus b and then minus 3x, so minus 3bx, but I factored out the x. And then I have minus 2cx. So again, factor the x out of each of those. And then what do I have left for constants? I've got 1a, I've got 1b, and I've got 1c. So how am I going to rewrite this into a system of equations? Well, I've got 1x squared, so I've got 1 equals 3a plus c. I've got negative 1x, so negative 1 is going to equal negative 4a minus 3b minus 2c, which I'm going to make this easier on myself and just write it as positive 1, positive 4, positive 3, and positive 2. And then for my last one, I've got 1 is equal to ABC. So 1 equals A plus B plus C. So this is my system of equations. How am I going to solve a system of equations with 3 variables? Oh, I promised you in the last video I would take my time through this one, so let's do it. Now, as promised, I'm going to take you through how to solve a system of 3 equations, in case you have forgotten. When we did an example like this previously, we used our linear algebra skills. Some of you haven't taken linear algebra, so that might be super confusing. So if you have, feel free to solve it using matrices, but we're going to go ahead and use just our regular old substitution and elimination type of strategies that we've learned so long ago. And I'm going to choose to use substitution to begin with, so I'm going to call C 1 minus 3a. So what that means is I'm going to take my first equation and I'm going to replace c with 1 minus 3a and then simplify it down so that I just have a very easy to deal with equation. So this is a plus b and then plus 1 and minus 3a. I want it to be so that a and b are on the same side and the constants are on the other, so I'm going to subtract 1 from each side. So that's going to give me 0 on the right side, and on the left side I have an a and a minus 3a, so that's minus 2a, and I have a plus b. So there's my new equation 1. And then for equation 2, I'm going to do the same thing. I have 4a plus 3b plus 2 times, instead of c, 1 minus 3a is equal to 1. And now I'm going to simplify as much as I can. 4a, 3b plus 2 minus 6a equals 1. I'm going to subtract 2 from each side because I want the constant on the right side all by itself. And on the left side I have 4a and minus 6a, so negative 2a, and I have plus 3b. So what I have now is I have a system of 2 equations, each with a and b. So I'm going to choose to rewrite this equation as positive 2a minus b equals 0, which is totally legal because basically I took it times negative 1. And why did I do that? Because now I'm just going to combine these together. So I'm going to solve by elimination. And by that I mean I'm going to take my 2a minus b equals 0, and I'm going to line it up with negative 2a plus 3b equals negative 1, and I'm going to add them together. And in doing that, I'm going to get rid of a. 2a and minus 2a cancel. Minus 1b plus 3b gives me 2b, and that's negative 1. So b is negative 1/2. So if b is negative 1/2, how can I find a or c? Well, I can find, using this equation, 2a minus negative 1/2, because b is negative 1/2, is equal to 0. So obviously this is adding. I'm going to subtract 1/2 from each side, so 2a is equal to negative 1/2. Then I'm going to divide by 2 on each side, so I'm going to get that a is negative 1/4. So I have an a, and I have a b, and now I have to find a c, and the c, I'm just going to use this expression. So c is going to be 1 minus 3a, and a is negative 1/4. So c is 1 minus, well, minus a negative means I'm actually adding 3/4, which means c is 7/4. So what do I have now? I have that my generating function, g of x, going back to, obviously I don't have it on this page. Remember, we had a, which is negative 1/4, over 1 minus x. And then we had b, which is negative 1/2, over 1 minus x quantity squared. And then we have plus c, which is 7/4. And then that was 1 minus 3x. So that's where we are so far. And now we get to finish up. So how do we finish up? Well, remember that g of x, this, I'm just going to put the negative 1/4 out front. Remember that 1 over 1 minus x, we're just looking for what's a sub n. So a sub n for 1 over 1 minus x is just 1 to the n. And then if I rewrite my second one, I'm going to write the negative 1/2 out front. So this is 1 over 1 minus x quantity squared. Again, what's a sub n for that? Well, again, you can look back at that table or look back at video 8.4.2 where we actually derived the function. This guy was n plus 1. And for our last one, we had 7/4. And then we have 1 over 1 minus 3x. Well, 1 over 1 minus 3x, a sub n for that is just 3 to the n. So now what? Well, now I'm just going to simplify as much as I can. So g of x, obviously 1 to the n is just 1, so I just have negative 1/4. This guy in the middle is minus 1/2 n. And then minus 1/2, and then I have plus 7/4, 3 to the n. So the only other thing that I can do is combine the constants of negative 1/4 and negative 1/2. So that's going to give me, and you can write them in whatever order. I've got my 7/4, 3 to the n. I've got my minus 1/2 n, and then I'm combining negative 1/4 and negative 1/2 to get negative 3/4. This is our explicit function. So from start to finish, that's all of the steps that you will need to take. And of course, you can check your solutions for A0, A1, A2, and so on. We're not going to do that on this page because I have them on the next page. So again, we have our generating function. Our generating function gives us the value of a sub n at any value, so this is just an explicit function. Now if we use this recursively, notice I'm just redoing what we did at the beginning, right? We said a sub 1 minus 3 a sub 0, a sub 0 was 1, that gives me a sub 1 is 4, and then I'm just repeating that process. So I got 4, 14, 45. So let's check those using our generating function. Again, this is my generating function. I'm plugging in 1. 1 gives me the solution of 4. Plugging in 2 gives me the solution of 14. Plugging in 3 gives me the solution of 45. We, in fact, are geniuses and have found the explicit function. I suggest that you take a break if you're able to at this point, but what I did want to do is go through one more example where we do the first part of this question. So previously we had a question where I gave you a generating function that was 2 over 1 minus 3x plus x over 1 minus 5x, 1 minus 3x, and then plus negative 2x squared divided by 1 minus x quantity squared, 1 minus 3x. And we did a lot of work. This was last video, 8.4.6, and we took that and we turned it into this explicit function. What we're not very good at yet, because we've only done it once, is actually going from here, which is our recurrence relation, to here. So that's what we're going to do now. So if you need a break before you do that question with me, feel free to take one. Otherwise, we're going to just get this done. So if you'll recall, the last time we did this question, I made you kind of write out each series, and then we added up all the things and we found the patterns and whatnot and whatnot. We don't have to do that anymore. You have graduated. Congratulations. What I'm going to do instead, I'm going to take everything, I'm going to turn it into summation, and I'm going to multiply it by x to the greatest value of n, which in this case is n plus 1. So here's what that's going to look like, and I'm just going to try to color code as always. So my very first value becomes the summation as n goes from 0 to infinity of a sub n plus 1, and then I'm multiplying it by x to the n plus 1. And then I have equals, and I've got 3, and a sub n is going to be n equals 0 to infinity of a sub n, and again I'm multiplying by x to the n plus 1. And then I've got plus 5n, so that's the summation as n goes from 0 to infinity of 5 to the n x to the n plus 1. And then I have my last one. What color am I going to use? Yellow. I have my last one, which is minus 2, and then the summation as n goes from 0 to infinity of n x to the n plus 1. Now, keep in mind that what we're going to do is we're going to say, whoops, my colors aren't cooperating with me today. We're going to say let g of x equal the summation as n goes from 0 to infinity of a sub n x to the n. And then we're going to do our best to replace values with g of x. So let's look at the first one. G of x, if you'll recall, my colors are frustrating me. G of x gives me a sub 0 x to the 0 plus a sub 1 x to the first plus a sub 2 x squared, and so on. If I look at this first value, this would actually be a sub 0 plus 1 x to the 0 plus 1. So my first one is going to be a sub 1 x to the first. So again, we're missing this value. So what I can do is I can say, if I took all of this and subtracted a sub 0, it would in fact be g of x, right? I'm sorry, if I took g of x and subtracted a sub 0, it would be the function that I have. So this value is going to become g of x minus a sub 0. Again, because the way that it's written now, my first value is right here, so I have to take the generating function and subtract that first value. Now for the second value, I have a 3, and I have a situation here where I have a sub n and then x to the n plus 1, and you always want those numbers to be the same. So how am I going to make those numbers the same? Well, I can't screw with a sub n, but I can deal with x. What I can do is I can take an x out here, and by doing so, that's going to give me a sub n x to the n, because I factored one x out. So what does that give me? That gives me 3x, and then all of this is in fact the generating function, g of x. Okay, let's take a look at the blue one. Again, this is not the power series. This is not going to be replaced by g of x. However, I still have this issue where I've got 5 to the n and x to the n plus 1. So what I can do is take out an x, and that's going to give me the summation as n goes from 0 to infinity of 5 to the n x to the n, or of course I can also think about that as 5x to the n. And if you'll recall, back when we were learning all about those fun series, we knew that we could replace that with 1 over 1 minus 5x. And then for our last one, again I have a minus 2. I still have this problem with n and x to the n plus 1, so again I'm going to factor out the x so that n and x to the n are the same, so I've got 2x. And then I've got the summation as n goes from 0 to infinity of n x to the n. And if you'll recall from our example before, this was x over 1 minus x quantity squared. And again, we went through a very specific example for this one in the second video from this series. So here's where I am so far. Let's see how much we can reduce this. This is g of x. A sub 0 can be replaced with 2. Because I know that I want g of x's to the same side, I'm just going to go ahead and subtract the 3x g of x. And, oops, this is an equal sign. And now I'm going to go ahead and pop that x over the top. So I've got x over 1 minus 5x. And I'm going to pop that 2x to the top. So that gives me minus 2x squared. And then 1 minus x quantity squared. Now keep in mind, I'm trying to get g of x by itself. So my next step is to get the values, get the terms that have g of x on the left side and everything else to the right side. So that gives me g of x. That means I'm going to have to add 2. So I'm going to add 2 to each side, and adding 2 on this side gets rid of that 2. So minus 3x g of x. So on the right side I have x, 1 minus 5x. I've got minus 2x squared, 1 minus x quantity squared, and then plus 2. And of course then I would say that this is 1 minus 3x. Sorry, let's put the gx out front. Gx, g of x, and then 1 minus 3x. Which means essentially, and I'm not going to recopy all of that, what I'm going to do is I'm going to take each side divided by 1 minus 3x, because on the left-hand side now, I'm just going to have g of x. And on the right-hand side, I have x over 1 minus 5x divided by 1 minus 3x. I have 2x squared times divided by 1 minus x quantity squared, and then 1 minus 3x, and then I have 2 divided by 1 minus 3x. So you can see I have 1, 2, 3 terms. Now we already did the second half of this question, again turning all of this into the explicit function, but that was a really good practice of the first half. So again, the first half gives us the generating function. The second half, which is in the video just prior to this, goes from this generating function to this explicit function. Honestly, you should pat yourself on the back for making it through that section. I feel that the book did a horrible job of explaining a lot of it, so I probably went a little bit overboard, but I don't apologize because I think it was very important to have those great examples. So up next, you're actually just going to take a nice big sigh of relief because it's going to be fairly straightforward, easy stuff, graphs and graph models.